Hello students, welcome to this presentation of question 12 of our paper 2 exam preparation series for mathematics, and I believe that you have a pen and paper. You are working along with me as I present the solution, the thinking process, and just the whole picture of the entire question. All right, so let us take a look at the first question under question 12. Here it is. Okay, so we are asked to get the equation of this line right here that passes through the center and point P. Okay, that is the situation that we need to talk about, and we understand that tangent is perpendicular to the radius. That is our radius. Okay, so we need the equation of that line right there. Okay, so how can we move? We are given the equation y equal to negative 2x plus 6. What does it represent here? It represents the equation of the line APB, all right, where A is the y-intercept and B is the x-intercept. So what is the value of that y coordinate? It's 6 definitely, so we have 0, 6 there. And what will be the x-intercept? We transpose it, divide by negative 2, you get a 3, right? So that will be a 3, 0. Okay, so that has given us a clearer picture of what is going on. And because of the 90-degree angle there, or the perpendicular nature of the radius line as well as the tangent, we know that the gradient of the radius times the gradient of the tangent, we get negative 1. Okay, so this guy comes in there. We have the gradient of the radius times negative 2 equal to negative 1. Therefore, the gradient of the radius is equal to a half. Does it make sense? Yes, there's an increasing function, okay, and therefore it will have a positive gradient, as we can see from the construction. Okay, so we have y is equal to half x plus c. Now we're looking for the value of c. Where will it cut the y-axis? Definitely it will be below 2 because point P is there, it's on the line, and that is 2. What will that be? Let us determine that. Okay, we understand that P lies on this line as well, so that we can substitute P. So we use point P, 2 and 2. So we have 2 equal to half times 2 plus c. That gives us a 1. 2 minus 1 gives us a 1, and therefore c is equal to 1. So to cut the y-axis at 1 makes sense. So therefore the equation is y equal to a half x plus 1. And that takes care of part A. Alright. Let's go to the second part of the question, 12b. Take a look. Okay, so we have a complex question that we need to respond to now. We are looking for the minimum distance from the circumference of the circle to the x-axis. Where's the x-axis? There. Okay, so we can talk about the lowest point on this circle, okay, closest to the x-axis basically. So we are looking for this distance here, okay, such that it is a minimum. Okay, so at some point on the circumference, that distance is obtained. Okay, what do we know? Center to circumference, the distance there is a radius. Okay, and if we can find the coordinates of the center A and B, that will represent for us what? B. So B minus R will give us definitely the minimum distance. Okay, so now what can we do? We know the following. The equation of a circle is represented like this. Okay, we have 2 points that we can use, P and T. So we have 2 minus a square plus 2 minus b squared is equal to r squared. Also, for t, it will be 5 minus a squared plus 1 minus b squared is equal to r squared. And therefore, we can equate these two left-hand side expressions since they're both equal to r squared. So we notice we have two variables and we need to solve for both of them, which represent the coordinates of the center. So we need another equation. So this can be equation 1. How will we generate the second equation? From the previous question, we have obtained the equation of the line, and it has the gradient 1 over 2. Okay, so we can use this set of points or that set of points to get the expression of the gradient using the coordinates. So b minus what? 2 over a minus 2 is equal to a half. Okay, remember the equation of this line, we obtained it. So actually we just need to use this set of points because that is a totally different line that we're going to get there. Okay, so that is a half. Okay, that is the gradient of that line. So how can we proceed from here? Cross multiply. We have 2b minus 4 equal to a minus 2. And therefore, we have 2b minus 2 equal to a. All right, when you transpose. So this is equation 2. So wherever we see a, that guy will go in there. Okay, and the entire equation will be in terms of b. We'll be able to solve for b, come back here and solve for a. Okay, it's a long arithmetic process, but let's go for it. So we have 2 minus what? 2 here, 2b minus 2, okay, all square plus, let us expand that one, 4 minus 4b plus b squared equal to, what's going to happen there? 5 minus that, 2b minus 2 all square plus, can just expand this as well, 1 minus 2b plus b squared. Okay, so we're going to come back here to have what? 2 plus 2 gives us 4 minus 2b plus, okay, that will be 4 minus 1 gives us a 3 minus 4b plus 2b gives us minus 2b, and b squared minus b squared, they fall away. Okay, so we have 5 plus 2 gives us 7 minus 2b all squared. Now we expand the side, we have 16 minus 4 times 2 times 2 is 16b plus 4b squared plus 3 minus 2b equal to 49. 7 times 2, 14 times 2 minus 28b plus 4b squared. All right, so let's see, 4b squared minus 4b squared, 0. Okay, so minus 16b minus 8 minus 2b and minus 18b, and we have that guy, that side, minus 28b when it comes over. So we have 28 minus 18 giving us 10b this side. We have 16 plus 3 giving us 19. Okay, we have a 49 there. So 49 we minus 19, we get 30. And therefore b as the y coordinate there of the center is equal to 3. Okay, what do we do now? We come back here and say 2 times 3 minus 2 is equal to a, and therefore a is equal to 4. So the coordinates of the center is 4 and 3. Okay, good stuff. So since we have the coordinates, can we get the magnitude of the radius? Yes. Okay, So the radius is equal to the square root of what? 4 minus 2 whole square plus 3 minus 2 whole square. Okay, the 2 square, 4, 1 square, so this gives us square root of 5. Good. So what do we know? We know that the radius here is equal to the square root of 5. The b value is 3. So 3 minus square root of 5 gives us the minimum distance that we're looking for in cell form. Okay, if you want to take it to decimal format, definitely you can do so. So yeah, it was an interesting problem, and here's the solution. So guys, this takes care of question 12, and we're now heading off to our last question of the paper, that is question 13. All right, remember our design intention is to achieve excellence, and that is what I want for you, and I believe that you've been working consistently up to this point. So see you in the next video. Thank you for watching.